All right. Thank you, everybody, coming today, including those online and here residential. So thank you very much, and I apologize for being late somehow because of some technical problems. So first, before Kai start, I want to say that one of the committee member, Professor Kim, cannot come today or join us remotely today because she have a medical urgency. So she's taking a medical leave at this moment. But we will provide a video recording for her, and so Kai's final defense result, we will get her opinion before, the final results comes. Okay, and so we will start from the Kai's presentation. So after presentation, we will have a QA, and then we will have some committee discussion, and we will have a preliminary decision today, and then we will give the video recording. We will give the preliminary result to Professor Kim, and after we get her opinion, and we will release the final result for Kai. Okay, I'm sorry for this complexity. All right, so we can start. Kai, it's your show time.
Okay. Yeah. Thank you, Professor Liu, for all the preliminary explanations. Yes, some points I want to mention as well today, and thank you everyone.
This video. Yes, it's good. All right.
Yeah, and thanks everyone for coming today to listen to my PhD dissertation defense. Thank you. Now let's get started. So today's topic, and also the topic of my PhD dissertation, is titled "Memory Enhanced Large Language Model Adaptations for Human-Centered Intelligence." Before I jump into the details of what I have done for the past 4 years and all the research paths I have done, I want to introduce my committee members. So Professor Xiaozhong Liu, which is also my advisor, and Professor Rai Shrika, and Professor Frank Zhou, and also Professor Yejing Kim, who is on medical leave now. Thanks for the support from my committee members, and thanks for serving as my committee members. Thank you. So today's agenda would be, I will give some background of how I formed my research first, and then I will explain details of the overall and research goal, and then I will jump to the what I have done for the research project in the past 4 years. And then I will show some results I have delivered, and in the end, I will do acknowledgement, and also some findings can also be seen in the appendix. Yeah. So today we've already seen a lot of development in AI area, especially in large language model. We see large language model can help us to write email, to handle multitask, to do a lot of daily work for us. But we know that when we use large language model, we know that is large language model. That is because the intelligence level, from my opinion, is not like as equal as human intelligence. So one sentence to conclude my research goal here is to approach the human level intelligence here. So I was trying to find what's the gap between current large language model and the human level intelligence. And then I choose the direction of memory. And here are some quotes from the state-of-art researchers' opinions in memory. So, what is memory? So, before we dive into or explain the definition of memory, I want to first give a background on what currently NLP is and what currently the AI intelligence is. So, back to a very quick recap. So for traditional NLP, we have language modeling, which is on this side. Then we have something like next token prediction. We have probability modeling to predict what would be the next word, next sentence, something like this. This is what we call traditional NLP, but it is not so efficient, and it has limited generation space. So then we shift to generative NLP, which is actually the scale up of traditional NLP. So we we scaled up the training corpus, we scale up all the generation space and the computation resources, and then we have the current large language model. But that means we have a high compressed information database for us to use, which you can see we can ask GPT questions and they give answers, but that is not intelligence. So where should we go to fill this gap? If we think about this question, I want to make a simple comparison between human and human intelligence and the artificial intelligence now. So we see the first level is data. We see when we see current large language model, they trained on massive data, but is a large language model as smart as ours? No, because but we have limited data, so not as much as the large language model have learned or have seen. So this is the first gap here, the first level here, data, large language model beat us. But for the second level, the modeling part, we see limited data, but we present a higher intelligence here. So what's the gap here? This is a learning method. But we've already seen a lot of research work. I'm pushing on this track. So on the learning side, we are approaching. So this is on the learning side. Then we see the high level intelligence here. So on the learning side, we see we are approaching, but the approaching, but this kind of approaching is more like how to more accurate or more properly to map the input to output. This is not human intelligence. So how human learn things? For example, if I know the word, I know the English word yellow, I will learn the word banana very quickly. That's why. That is because we have the associative learning ability, and this kind of learning gap is currently from my view is a huge gap here for between human intelligence and artificial intelligence. Then how to solve this kind of gap? This is also what I have been doing in the past 3 years. So we call it memory. As for human beings, we have short-term memory, have long-term memory, and more even we have associative memory, as I just explained it. So with this kind of memory, what can I do? I can simply recall some facts, something happened recently, and I can associate some things in the past or from others that I can use for my current new scenario. So this is actually the gap. So imagine for LM, how can LM adapt to new things? You train it, you add new data, you give more things, right? You give data and it trained in its original way, but for human, it's not. Because we see a new scenario. The first thing we want to see is we would think of is to retrieve something relevant and get the most relevant things happened before, and then we learn from it, and then we adapted this kind of patterns to my current questions. So that's what memory can bring, can fill, how memory can fill this the intelligence gap here. So first thing, long story short. So first thing memory can provide is knowledge storage. We can store something, either external knowledge or the things happened before. So that's one thing, knowledge storage. And the second thing is the personalization. So imagine we are not only want to AI to help us in all kinds of daily works. We want the AI know me. Like I don't need to. If you are using ChatGPT, you will figure out that you need to think about the prompt every time, and sometimes the task is complicated, so you need to have a very long prompt to type into the ChatGPT, and then maybe you need to fine tune it a little bit because it's not the one-time answer generation, and it's not one-time satisfaction. So if an AI knows you, it will adapt to your it will adapt to your preferences as you have done in the past. So one thing memory can do is personalization, and also this is one thing I feel is very important in the next 5 years. And another state is the transition state. This is I have concluded it. This stuff from the associative memory scenario. So transition stage is more like the problem I just said. Like you learn things from others, you learn things from your previous experience instead of training from scratch all the time. So with this background, I have one sentence to conclude my research goal here. It's approaching human-level intelligence via memory in the era of large language model. And next, I will explain in the past 4 years how I step by step approach this research goal. Overview of my PhD research here is 3 step. Actually, the intermediate, the one in the middle, the graph NLP. Actually, why I put it here? Actually, this graph NLP project is the first projects I have done for my PhD journey. But I put here because this is more like a foundation. A lot of my knowledge is learned from the graph NLP stuff, and then I can push the memory relevant research more quickly and smoothly, and then I shifted to my current understanding of my research and my future research career. Yeah, long story short, so for the past 4 years, I have delivered 9 peer-reviewed publications and 4 benchmark dataset. So the next agenda for today's presentation would be dive into in each work. I will do it in a hierarchical structure. First, give the project scope and then step by step is explained and how this project I connected to form my current research. Okay, so first let's look at the graph NLP. When we talk about research terminology, so for a researcher, you always want to know what is the term and how this term works and why we are investigating this kind of a term. So what is graph NLP? It contains 2 words, right? The graph and NLP. So we look at the NLP, especially the traditional NLP. So we have word modeling. We have like bag of words. So and we have the language modeling, which is basically the next sequence prediction. So it's more like a sequential prediction prediction problem. If you are familiar with Markov chain, then you will know each word or token is independent, and you will learn the next token based on the previous token. So that's what we call sequence here. And what is graph? Graph is more like a topological structure that can provide you some kind of relations or predictions. So if we think about the traditional NLP tasks, which is 3 main tasks: entity recognition, relation prediction, and also the summarization. So if we look at the traditional NLP, we will see that actually the things graph is doing and the traditional NLP is doing is actually aligned. So when we do traditional NLP, we predict the relationship between words, we predict the next words, and we do a summarization on all the relation patterns and the tokens. And for graph, we do the same thing. We predicted the node, we predicted the relations, and we use the whole graph as representation to do some summarizations. So actually they are aligned. So can we benefit from this kind of alignment? And the answer is yes. So dive into the biomedical domain. What is the problem here? Oh, this is the show up of the connections between traditional NLP and the graph structure. So if we look at the biomedical domain, which is how I conduct the graph NLP here, we see the tremendous opportunities in the biomedical domain. That is, we see increasing amount in the PubMed Central Publication Database. So how can researchers to quickly find what they need or what they desired? That's one thing. And also in the real biomedical domain, in the medical domain, so can we somehow learn the representation of drug and know what kind of drug we can recommend it to patients and give some reasons that which is explainable AI. So before ChatGPT, I think this is now if we look at from now, this is like a basic intelligence. But back to where ChatGPT is not show up. This kind of intelligence is actually very big. It will helps a lot. So I did 4 works on this, so I only list 3 because one of the work is I co-authored, but I will mention it a little bit here. Yeah, here are some statistics you can to prove my statement that the publication is increasing tremendously, and for my first year, I have done some efforts to speed up this kind of challenge for researchers to quickly get what they did out. So before I go to the methodology, I want to quickly show something that really matters. So which is the SOTA. We want to understand the baseline, and we want to understand how I made the improvements. So if you have the baseline, you will understand my improvements more clearly. So first one is on the extractive methodology part. If we look at this case, on the very upper box, this is a biomedical document. I only list like a paragraph here, which and also something some context which is not important are omitted here. So we see some entities that highlighted in blue. You can see the skin and cancer rows and the skin cancer. So they are like similar or connected or share some kind of relationships. So if we use NLP techniques, actually we want to what we can do is to put this sequence into the model, and then the model predict the next word in your predefined vocabularies. So this is extractive methodologies. You have a predefined set that contains your entities, your words. Then the job you are doing is to select one from this kind of storage. So the search space is limited. That's for extractive methodology. And then we shifted to generative methodology. Basically, you have unlimited search space. You have the entire internet as your search space. The only thing you need to do is to calculate the possibility, and then you generate it. So basically, generative methodology is actually a scale up of extractive methodology. So now we don't have the limited search space, but another concern happened. It's like if you pay attention to the research of large language model, you will see like 2 years ago, you will see a lot of hallucination problems in large language model, which is one generation. It basically is predicting your next tokens. So the model don't care the next token you outputted is trustful or not. It only cares that this token has the biggest possibility. So we have trustworthiness concerns for generative methodology. And what things can help to reduce this kind of trustworthiness? Imagine we have a graph. That graph is connected. For example, in the social network, Professor Liu and I are connected. Even though the next token of facts generated on my side is some kind of other things, but if you know that I am connected with Professor Liu in the social network, so you will have more weights on facts about similarity between my side and the Professor Liu's side instead of maybe President Trump's side, right? So graph methodology can provide this kind of reasoning and connection, topological connections. But it also have some kind of weakness here, which is like guidance. You will simply have a path going through very deep, but as your hope goes wider, the connection, actually the topological relation is weaker. Then if you output this kind of information, that you will have some kind of information loss. So the first work on my side is to dive deeply into this three methodology, and then come up with a new methodology that can solve the weakness of them. So an intuition here is this example. This example serves as the base for my all the graph NLP project. So how graph structure can be applied to NLP tasks. So we all know that in NLP tasks we have tokens, we have relationships, we have a lot of other concepts here. So in graph, we can use the node to represent it maybe on this example is dragon or diseases, this kind of thing. On NLP biomedical documents, we can use like abstract, use whatever you want for your task, which we call it the entity. So this is the minimum process unit you can use for your node. Then you use the text embedding, which we call it the semantic embedding, as the initial node embeddings. Then you can do reasoning, do or assign the topological relationship based on graph learning to your NLP semantic representation. This is how we connected the graph and NLP. So two words connect together, graph NLP. Entity definition, relation definition, and then you can learn based on the semantic representation to have your overall representations. So here comes my first paper. So the first paper is investigating the publication side. It's not diving into the biomedical drug side. So in this work, the input is the biomedical publication, and the output is the triplets. So basically, what we need to do is given a biomedical publication, we want to know all the triplets that can represent the highlight of this work to audience. We want to generate these kind of things to readers. So what we did is we first extracted all the entities here, and then we form a graph here. So this step we call it extraction. And then what is different from the previous work, the extractive method and the generative method, is like we all know that extractive method is very trustworthy and is very accurate, but it lacks some kind of imagination, I would say. So what we did here is a contextualization step here. So we trained the model to predict to recover the node of extracted graph, so that the model can learn like the connection or the underlying patterns of this graph. And then when we do contextualization, we can observe or we can obtain a new unseen node from external large graph. Then we use we put it on the to expand the graph so that we can see something relevant, but it is unseen before. That way we have the node representations. And the next thing is next track in parallel is the semantic learning. So we have abstract, we have introduction, we have citations. So if we only look at the entity relation graph, we will lose some kind of information. So we only know the entities, we only know the relationship. It's not enough for you to predict the main content of a publication. So we want the semantic information as well. Then we have semantic information. We gathered all the semantic unit, and we combine the learned topological representation, which is the expanded graphs representation, and the semantic representation together. We put it into a sequential generator, step by step. For step one, we generated the first entity. For step two, we generated the second entity. Then we predicted the relation, iterated this process, then we can have all the triplets we want from the publication. So this is my first work. A quick, if you're interested in this work, you can always track or any other work I will introduce next. You can always track it in my Google Scholar. So here I only highlighted the comparative study results here. So you see that this work called DIGN. So achieves an average 4.91% improvements in F1 score. So the average is meaning like the average compared to extractive methodology and generative methodology and the graph methodology solely. So we see the potential to improve the trustworthiness and most importantly, the reasoning ability that graph can provide. this serves as the foundation for my future work on generation side. So this is more about node expandation. So what is another thing important on graph is the relation. This work just accepted by bioinformatics in January. This work I actually co-authored. So I didn't show the results because I felt like you would be misleading if I use the results by mistake. So I can simply elaborate the connections here. So this work is more on the relation part. That is, there is an assumption that is like if a paper is citing another paper, so the relationship is like citing and cited. So if two papers are cited, citation connected, then that means these two papers may share something in common. So this is also a topological relationship, right? So based on this kind of relationships, we instead of understanding the node representation or expand the node, we use the relations for the decoder to generate the triplets. So this is another explorations on the edge side of a graph. And once we have node, we have citation, we have relation predictions. So corresponding to NLP, we've already know how to expand the entities. We already know how to predict the entities. We already know how to capture the underlying patterns or relationships between entities. The next thing, most importantly, for real world applications, providing triplets to researchers doesn't make any sense, right? We want to provide something like summarization. We want to present something like reasons to the researchers or people caring about the publications. So is there a way that I can learn some representation to benefit for all downstream tasks? So inspirations from node prediction and citation and the edge prediction. Here comes the representation learning. There is no downstream task for this. So the task here is to learn the well-represented entities and the relationships so that the whole graph or the sole node embedding and the edge embedding can be used to perform different downstream tasks. This is actually one of my favorite publications in my past years. I propose a lot of mathematical theory in this work. So here the input is a corpus. So for each paper, then we go to things. Similarly, entity relation graph. Then we ask the entity relation graph to learn a representation, and we ask the language model to learn a semantic representation. So topological representation and semantic representations. What is novel here is we leverage the idea from probability. We use a W distance. So high intuition here is like when you have a publication, either you give the triplets, the concept triplets, or the summary. They should be very close, right? They should talk about the same thing. So if your graph is outputting something irrelevant to the semantic summaries, that means the model is not good. So what we did here is we use the W distance to control the distance in the W space between graph representation and the semantic representation, so that it can learn its own attribute. For example, graph representation, we need the topological representation. For semantic representation, we want the semantic meanings. So we want you learn your sole job at the same time, close together. And then we have the learned representations combined together as the node initialization. We have a multi-dot graph. Then we do the regular graph learning on it so that we can have a whole graph representations. So throughout this pipeline, we have node representation, we have edge representation, we have the multi-document representation. The benefits is we proved that this kind of methodology actually improves the performance on all kinds of downstream tasks we care about back to 2022. document classification, which you can regard it as node classification, we see the improvements is around like 2%. And you see the citation predictions improves around 4%. And overall, what do we care about the most? When we have the whole graphic representations, we have the multi-document summarization. You also see some improvements on the standard machine translation metrics, which is ROUCH. We now have learned the node side, the citation side, the representation side. What's the real benefits of this kind of learning? So here comes to this workshop paper. So this paper is actually an application paper. So what we done on this paper is we sampling concepts from the external knowledge graph, and then we also have some informations from clinical trials and PubMed Central publication based on the sampled nodes, so that we have what? We have the nodes, we have the relationships, we have the semantic copies. Then we merge them together to do instruction adaptations to ask the LM to tune the LM to answer the questions. For example, can you recommend a drug for diabetes person, given the person's facts and some kind of background information? Then we recommended the drug, and more importantly, we give the reason why we recommended this kind of drug. So all three in one application papers. A summary on the project one is I have learned a lot through the project one. The graph side, you will see some clues in my following or recent research. You will see some graph, and you will see some my understanding on the probability distance stuff. So this actually forms the knowledge or the base of my overall research, and you will see connections between. I made 4 papers to achieve what we call now is basic intelligence, or actually more engineer work. So if you connected my 4 papers together and make a well pipeline and well piped engineer work, then you will see it will be convenient. It will understand node, understand relations, and more importantly, help you generate reasons. But actually, ChatGPT can do it. Can do them all in one. So, So let's record the goal here. I want to approach human intelligence. Now we are in the stage of basic intelligence. So what is next? Let's embrace the rapid AI stage. So the memory enhanced large language model, the second project. I have already elaborated why I choose this topic. The high level reason is I want to fill in the gap between the basic knowledges and basic intelligence and the human intelligence. And I think memory could be the key to achieve this. So I have done actually 4 I have done actually 4 work here, but I highlighted 3 because the other work is like lightly use memory, and it's more on the on-device intelligence side. So I move it into the project 3. Okay. So let's recall the human memory system if we want to do the memory research for large language model. So for human, we have short-term memory, we have long-term memory. Short-term memory is more like a working memory. You will remember everything. Like what do you have for breakfast? What just happened 15 minutes ago? You will remember everything once it happened. And maybe after 1 week, after 2 weeks, these things doesn't matter anymore. You will never recall it, so you can refresh your working memory. So this is the beauty of short-term memory. You can quickly when human tries to understand or answer the kind of factual questions or some all kinds of questions, recommendation questions, you first look at your working memories, since it covers everything. And the beauty of long-term memory is unconscious. Imagine you are driving. You go to your car. You won't like record the first step I need to do, the second step I need to. No, you don't. You just put your hand on steer and put the pedal and step on the pedal, and then you drive. So this is unconscious. So this is more about your preferences, and this is more about the facts, the preference, the intricate facts of you as an intelligence agent. So this is the beauty of long-term memory. It is fast and it is conscious. And one more memory I want to call it out is the associative memory. This is actually more about how human learns from memory. You recall things and you move the underlying patterns from the old stuff to your new stuff. That's why some people are smart, some people are, it depends on your speed, learning speed to move your older patterns to the new patterns. Okay, so take this in mind. I conducted my research. Let's first introduce the basic structure of existing memory system. You will see a lot of work. Actually, I would say 80% of memory-based work are following this kind of structure. You have a query, then you have a memory as a storage. Then when the LM tries to understand to answer your queries, you will not directly answer. So you will first go to your memory to retrieve some relevant things and then put them together into the context and ask the agent to give an answer. So a lot of work is considering how to organize this memory and how to provide the most accurate or proper information for query. So that's a little bit aligned with the RAG problem. And another thing is memory utilization. How once you have the personal information, how you maximally use your memories, that is important. Let's see my first work. I believe audience have seen this work a lot because I present this one as my research qualifier too. So in this work, long story short, this is my first exploration in memory enhanced large language model. So on the right fingers, you will see on the upper box the historical string, which is the dialogue history of a user. Imagine you have a conversation with ChatGPT. So you have the first conversation 1, conversation 2. You have a lot of histories, and then it goes two directions. On the right part, it goes to a memory management system. So you have a coordinator to decide it if your utterances is salient or not. So if it is salient, then it stores into working memory. That aligns with how our humans memory, right? So we won't like remember everything. We just remember things we care about. So if it is salient, then it goes to working memory. And what's the next is not every memory in working memory serves are equal. So some memories are important. For example, if there is a dialogue, it's like I inquired about diabetes stuff, and I told ChatGPT I'm a diabetes patient. Then once you detect this kind of information, you should directly send it to short-term memory or long-term memory because this is your fact, this is your, and it won't change in the recent time. So there is a mechanism. There is a mechanism that decided memories in working memories are important or not, and further push them into the short-term memory and the long-term memory. So this is if you recall this kind of structure is very aligned with how human memory works, right? Because that's actually the inspiration from for this paper. And then once we have a well-formed short-term memory, we have a well-formed long-term memory. What do we do? On the memory utilization part, we first retrieve from both short-term memory and long-term memory. Then we have context. So this work is done in 2023. Back to 2023, actually, the large language model is not that powerful. So we needed to mix the LM to fully understand the context. Actually, there is a thing I want to call out that when I mentioned the memory utilization, it actually highly depends on your large language model. So if your large language model is like very powerful, like today's Gemini 3 Pro, then actually it has a very strong ability or power to do anti-noise generation. But if back to that time, you don't have. So you need to do some kind of tuning or instruction here, which I've done here to make your LM best understand your context actually some of the work are still investigating this track as well. So once you understand your concept, once you understand the context you provided maximally, then it will provide some kind of a personalized response here. So this is the whole pipeline. And we see some improvements compared to without the memory, and also compared with this even the best large language model back to that time. We show that we only use the limited sized work, then we can achieve a very promising results. Actually, this work has been adapted by next generation Meta AI's personal intelligence. And the next thing is the MILP, which is a follow-up on the MALP. So on MALP, what we have done is more like a REG problem. You store things, then you retrieve things. So what is the limitations? You have limited for large language model, especially back to 2023. For large language model for LLM, you have limited understanding on the context. So it is possible, like you for human beings, we don't actually retrieve memory at most of times. So we directly, you ask me something, then I directly have so the generation and the retrieval is actually in parallel execution. It's not like I first do retrieve and then I do generation. It's not like this. So I'm considering if we can inject the memories into large language models so that you can have your own personalized large language model that you don't need to do retrieval. Actually, you ask something and some weights are activated, then you generate the things. So that's my intuition. And what I have done is I format all the person's historical trajectories in a very well format, like this. We have content. Now we have name, items, questions, answers. We all follow this kind of information either in biomedical domain or in Amazon, like help you write a review, this kind of task. So I put them together and all in this format, and I train a model. So what is the model? What is the model? The model is actually this one. It's a supernet. I try to inject I try to use the LoRa techniques into different layers. So the intuition by doing this is like large language model. You have different understanding on each layers. So in shallow layers, more patternly, and in deep layers, more semantically. So which layer to store the user information and which layer to do activation is actually the problem of injecting. So how to storage? How to store this user memories? I use LoRa, but I don't know which layer to store. And actually, I have tried, if you store it across the large language model all in one, actually you will need a lot of computation resource, a lot of alignment, and actually the large language model would crash if have hallucinations. So which layer? And which layer and how big the LoRa should be. This is a problem, and the key to inject the memories is. So what I have done, I don't know actually the parameters. So what I have done is to shift to the neural research track research. So I train a supernet which contains all kinds of parameters. For example, this parameter set is more suitable for dealing with summarization tasks, and this kind of parameter set is more suitable to tackle the classification task, etc. Then we have a supernet. Then once we have new task comes, we actually just need to search which parameter set we need to use, and we use this parameter set injected into the large language model as shown on the left box sub box here. So that you can perform the task well. And next thing I want to do is for personalized response. I want to do instruction tuning to let the generative style is more of user interest or more of user favor. So this is the whole work of this exploration. But this work has a big problem, is the scalability. So when you train the SuperNet, is it worthy to for a single user to have this kind of training time resource together to get a SuperNet for the single user? That's the biggest problem, and that's the reason why this work has been rejected multiple times. I really should highlight this work in my in my desk. So this work has been rejected for 5 times. This is the most rejected work of mine. And then we so RAG-based memory and the parameterized memory, so two explorations actually aligns very well with how human memory works. But there are something more. So associative memory, this is the work I have done in the past summer while I was intern at Meta AI. So this work is actually a dive deeper for the RAG-based memory, which is the MALP. So when you do retrieval, it's ideally you have short-term memory, you have long-term memory, you have working memory, then you coordinate them together to provide context. It is nature and it is simple yet effective. I like it, but the problem is as your memory goes bigger, you will have a problem that is similarity dense. And what is the thing you are trying to store? For example, if I ask the ChatGPT like, how's the NBA today? How's the tennis today? So basically, it will have a conclusion that you are interested in sports, or you are interested in NBA, or you are interested in tennis. But actually, for me, I like to ask the scores every day because you know when the game series happened, is happened from a range of date. It's not just happened on that day. So I may want to check it every time. So on every day, you have this kind of memory created. So what would happen? Your working memory would full of something very similar. So similarity dense. How we solve this problem? We use graph. This is the intuition from my first project. We use graph. Um we we actually merge your working memory into different topics. Then we use hierarchical structure topics to raw data to create it just simple to hope graph. This kind of graph is simple. It's a lightweighted, but it can help you to provide something that is very important. For example, topological relationship, and more importantly, the popularity. Imagine the Google. So how Google search works? There is an algorithm called PageRank algorithm. So that the PageRank is basically evaluate how many nodes are coming towards you, how many nodes are coming out of you. Basically, it's the citation relationships. So the assumption here is why Google search can give you so accurate the search results that you use Google, and Google almost have the dominated the search selection search option for the past decades. That is because Google treats every page as a certain node. So if you have for example, if the website the page you are viewing contains some links to other pages, or some other pages have links that contains your links. So that means you are popular. You are popular among the massive internet. So you will be retrieved as a top result. This is the intuition behind the Google search. So apply this kind of intuition in this work. We have the graph. Then we want to know what is the most popular memories of your mind, right? So in your memory base, what is the most popular? That has the most probability that it can be used to answer your questions. So popularity, but popularity is more like when you asking for recommendation questions, right? So if I want to say, can you recommend a restaurant for me? So your opinion matters. Your most popular opinion matters. But if you are asking the factual questions, for example, which restaurant did I go yesterday or last night? So these kind of questions, popularity is not important anymore. You just want to know the facts. So what can provide the facts? Semantic scores. The most similar stuff is the most accurate stuff. And another track in your daily queries is the temporal tool. It's a temporal side. So what happened recently is actually more important than what happened like 2 months ago, 3 months ago. So this kind of recency information, I also want to include it in the final retrieval system. So on the offline, the blue box, we created the graph. It provides the popularity, it provides the topological relationships. And similar to my first project's implementation, I used the semantic information as the node embedding. Then we can have semantic scores, which I call it relevance, to answer factual questions. And then we want to include the recency information. So I use a temporal large language model to do the temporal recency learning and provide temporal scores. And altogether in the green box, we have scores from 3 dimensions, which is query oriented. Then we have a final retrieval system to both answer the recall questions, factual recall questions, and recommendation questions, and even more the temporal questions. And this is very aligned with our associate map. So when we want to answer questions, we first find something popular in our mind, which is we always say what is on top of my mind. So this is kind of popularity information, and then it's a relevancy information. We want to know what's the most relevant to our questions, and we always remember the recently happened things instead of things happened 3 years ago, right? So associative memory. And it has been proved. This paper is actually very interesting. If you want to read more, then you can come to the Google Scholar to read the full paper. It's actually very interesting. Not just what I showed here, the comparative study. There is a query-oriented separation study here. It's very interesting for the results. So it actually has a lot of improvements than currently memory work like AMAM or the local work. So now we have explorations on short-term memory. We have explorations on long-term memory. So we also have explorations on the memory format, like the parameterized memory. So what is missing? What is missing for you to approach the human intelligence? Actually, it's a subset of associative memory. So it's the learning thing. This work is ongoing. So this work investigated the in-memory reasoning. So for humans, we don't use memories in a semantic way, semantic similarity way, right? So for example, if I ask like, can you recommend some restaurant for me? So this is more like you don't need to know. So semantically, so for example, for current large language model, semantically, restaurant name or restaurant descriptions or your past orders, that matters because that's most relevant to your queries. But what is other things that matters? If you are just met me at the first time and you want to buy me a meal, and then you don't have to know what I have ate in the past 14 days, right? So all you need to know is that I have that I'm a Chinese, and you want to have me some Chinese food. So sometimes we need something that is not semantically similar. We want something that really matters or helpful. This is more on memory utilization part. So what do? We have we have two memory side, which is individual memory and the shared memory. It's more like a community memory here. So sometimes we learn underlying patterns from community, from others. So once we have questions, what we need to do is to first retrieve our own memories. Back to your medium school, when you solve some kind of math questions, you don't know the questions. You won't like ask a GPT like what we did now. So what I have done for the past is like I first see if I know the terminology or the concepts the question is asking. Then I search the concepts in the textbook and I find more relevant informations. And then I solve the question. Maybe I will see some error questions that posted before by other students or teachers. I refer them. We call it references. So we have individual memory. We retrieve individual memory, but we do not directly use it. We go to shared memory to search some memories, and we combine these memories together. Again, search your individual memories. So learn from upper to bottom, bottom to upper, upper to bottom. So after certain iterations, we have a conclusion. We aggregate them together as the context for large language model to do generation. This is what we call reasoning here. So this work is actually still ongoing, and currently it's more on engineer side. So summary on project 2 is more on the memory relevant research, which is my main focus. So what I believe here is there are a lot of things we can do in memory. So reasoning associated to memory. So basically it's memory management and management and how you utilize it. So for memory, you have short-term memory, you have long-term memory, you have basic. So but for different questions, for factual questions, factual recall questions, you need to store everything because everything matters. Imagine you are having a lunch in a restaurant. Nothing important but your lunch in front of you, right? But if maybe 2 hours later, an officer come to knock your home and say, "Oh, there is a murder in the restaurant in that time duration," everything became very important, right? So once you have this intuition, so for different queries, factual queries, you need everything. You need every raw data because every raw data can be a clue. But for recommendation, for personalization, sometimes all you need is preference or immediate conversations. Actually, raw data is also important, but less important. So how you use it, how you maximum or properly use it, and more importantly, how you proactive leverage your memory is important. So the key differences between RAG and memory is the way you use it, I think. And the goal would be ongoing. So all my project together. Okay, sorry guys, I will do it quick. It's very close to the end. And so for the project 3, it's very simple. It's just personal intelligence. So all the intelligence work I have done, I believe. So before iPhone, we have like dumb phones, and then we have smartphones. So what is next? What is after iPhone? So we have AI now. We have powerful memory techniques now. So what is next? Next is on-device intelligence. I want to incorporate everything into the into the device end, so that you have your personal intelligence. I want AI to best serve for humans. This work is done during my internship at Google DeepMind. So here, actually, long story short, when we have device and large language model is small size, is a limited capability, and you have cloud side service side large language model, which is powerful but costly. So we want to so a solution here by Google is you route some queries that you are not confident with to the server and get answers. And for queries you are confident to answer it, you keep it in the local, then you answer it directly. That way you have a cost performance balance. But what is more important is privacy. That's a core research focus in this work. So I incorporated a learning methodology and the private memory to filter some privacy issues. And actually the results is pretty good. So summarization on my PhD career is graph NLP, which is the base of the foundation. You need to have a firm base to push your research, right? So this is the firm base. And then memory enhanced large language model. This is where my flexibility, my mind goes out. I learn from how to think about research, how to solve a research, how to solve open questions through this project. And then it's the personal intelligence, which this is my career goal. I list my next 5 years goal. So PhD journey ends, but my research does not. I joined Meta to work on wearables AI in the next generation, which I believe would be the next generation smart devices for individuals. Yeah. And at the end, I want to sincerely show some thank you to the support I received throughout my PhD career, especially for my great advisor, Professor Xiaozhong Liu. I know you really give me a lot of flexibility. So you know what is important for a researcher. I feel like is you are training my way to think about questions. So that's the most important. And honestly, every paper I have done is of my interest. I love them. So I sincerely thank Professor Liu for giving me this kind of flexibility and the support, either from financial or emotional support. They are all excellent. So very thank you. And my dear commit, back to the time last year here, I proposed the proposal, and you give me a lot of directions and the thinking, which actually helps me to form these slides and the overall structure of my PhD dissertation defense. So sincerely, thank you for all the support and the time you have spent on my cases. And my lovely family, they are not here, but still show them here. And one more additional family from last year, my dog Fluffy. She falls asleep now underneath. And my girlfriend Sydney for accompanying me here for like 3 hour drive from New York to here to do the defense. And my awesome lab mates, I still record the first year and second year. Yang and Jinghong helped me to run baseline experiments and help me pass the paper before I submit them. So sincerely thank you for all the discussions and all the support and all the time spent together so that I'm not going crazy during my PhD career. And all my great collaborations and mentors from Indiana University, which is the initial of my PhD career, and then the Damo Academic, and also University of Washington, and Meta Related Labs and Google DeepMind, and also all the help from WPI community, computer science department support and data science department support. Thank you so much. And yeah, that's all of my today's dissertation. Hope you have a wide and deep understanding of what I have done for the past 4 years, and very thankful for being here today. I know I'm out of time, but yeah, I leave 15 minutes for audience to give Q&As. Thank you.
Thank you very much. Yeah, I appreciate the efforts. It's clear. Kai did a lot during his PhD life, so which is great. Okay, but the time is for committee members and the audience here, so everybody can challenge him, ask whatever question you have. So let's start from the room. So any question from the audience here?
Especially for the research project and maybe next plan or a lot of things, any
Yeah,
kind of question.
whatever
Yeah.
question you have. Is there any?
Okay, may I ask a question?
Sure, yeah.
I saw you did a lot of work on the memory for large language model. Right? So how do you handle the situation when the memory is not very stable or it's not very consistent? For example, when children learn something new, usually at the beginning they will learn that, but next time they will forget that. So the memory is not very stable. So how do you handle?
Yeah, I think that's a great question, Yang. So, for memory consistency, this is actually an industry level questions. So if you are serving like a million for users, that's very important. So I think in academic there are two streams. The first one is memory management. If you recall the okay, you can recall my work, the associate mem. So you will see I not only stone the topics, the summarize the topics, I also stone every raw fact. So for consistency, the thing you need to do is to the easiest way is to stone everything. But then you will have noises, you will have unclean the memories. That's a big problem. So so a balance here is another stream or another track, which is very popular in academic. Now you see the memory R1. So, and this is actually the first work of applying reinforcement learning to memory management. So you can ask an agent to help you decide it or manage the memory. So that depends on how your reward function is. Like if you lost some kind of memory which is important, then you have a big punishment. And if you remember something that is trivial, that way you give a very limited rewards. So only great options you give good rewards so that it can have a good memory management. But actually, beyond how you manage the memory, I actually want to I want to have you to have a broader think behind this is what kind of memory you need. Like if you are answering factual questions, or if you are just help as a daily assistant. So for some questions, you need every raw data. You actually need to store everything. But for some data, or for some queries, you don't need you only need a specific memories, either associative, either high level. So you have these two type of memories. The way is actually how you use them. Yeah. I hope this answer your questions. No problem.
Thank you. And let's move to the committee member or someone online. So if you have a question, it's a good time to ask.
Yeah, I can start. Frank, do you want to go before me, or should I go?
Go ahead. Go ahead, Ray.
Yeah.
Wonderful. So, first of all, thank you, Kai. That was a great presentation. It was a pleasure being a part of your, journey. I joined let's say 2 years ago, and it's been a pleasure to see, how you evolve. Also, generally, but also with the slides that look, more, let's call them more complete. So I wanted to compliment you on that. It looks great. Everything aligned very well. So less apologetic, as I said last time. So you take authority on what you were doing and how it contributes. So great job. So I'll just ask one or two questions on project one and project two. So for project one, mostly, so one thing that I'm trying to wrap my head around, and can you go to, yeah. So you claim that all of the work that you have done, and here 39 was the slide I marked. You claim that all the work that you have done can now be replaced by an LLM that does it all. I tend to disagree, and this is for your own benefit, not against you.
Yeah.
This is for you. And I just feel like the fact that now you're gonna cross the evil road into industry, and you might claim this way from now on, but I do think there are so many niches within what you are doing there that I don't agree that an LLM can replace it all. An LLM can have access to methods similar to yours, or things like that, but I disagree. So I just wanted to hear you reflect on that, and maybe a little more, but also from your recent experience being out there, and how this translates into how an LLM actually works in practice.
Yeah, sure. Thank you so much for these suggestions. I feel like disagreement is actually very it's not good in our daily life, but I really love it when we are doing research, right? Because if you have disagreement, then you have a space to do research. So yeah, sincerely, thanks for pointing out. Because when I make this slide, I want to translate in smoothly. Yeah, but yeah, I agree that we have spaces to continue the project one, especially the graph NLP part. Yeah, and yeah, I hope I won't be the evil role to eliminate this kind of research, but yeah, we will see. We will see. Thank you so much for pointing this out. I love it. Thank you.
Yeah, of course. And another quick question about
Yeah.
project two, and then I'm done. Even though we can have a very long discussion afterwards, I'm always happy to have more discussions, of course.
Yeah, sure.
But so one thing that you haven't mentioned, I know that we were talking about it before, is RAG, and I can't help but make the comparison between your memory-based methods and RAG. So can you elaborate about this a bit? What is different in terms of methodology? Why is this not considered RAG, or if it is considered RAG, so why are you not positioning it as RAG? So can you elaborate a bit on that?
Yeah, sure, absolutely. Yeah, actually, this is a question that I've been always thinking and being asked for this type of research. So a too long generator answer is so existing memory system. I would like to consider it as a part of RAG. So so RAG and memory, they share a very similar way. You have database storage, then you have retrieval, then you have context appended to large language model to do generation. So in the format, they are very similar. But for the purpose and utilization, I would I won't say argue, but I will highlight some differences here. So the first one is for memory. If we see memory, so it's not only just about the raw data. It's always about something associative, something more realistic, like a time recency. So this kind of information is actually not included in RAG. So when we do RAG, we only have copies. We only have things that are relevant. We only care about relevant. Then we have relevant context. But for memory, actually, things are more complicated. Sometimes, because human beings are complicated. So for memories, we are not only store something relevant, we also store something, and also how to utilize something associative or something just irrelevant but proper. For example, if in a streaming dialogue, if I say, what should I buy tonight? And like just in the prayer turn, I said I will go to campus next week. So actually in semantic, in RAG scenario, these things are not very relevant. But that depends on your retrieval design. But mostly RAG system don't want this kind of information being retrieved. So when you say, what should I buy tonight? It's more about goods. It's more about needs. It's more about shopping places. That's what RAG care. But for personalization agent, for memory agent, if you are using a memory to personalize your assistant, then I'm going to shopping I'm going to campus next week. This kind of information is actually very important because you know you will need something for your next plan. So this associative stuff, like not semantically similar, but should be included in or enhance your personalization or user engagement experience. So this kind of information is considered in memory scope. So I would say in format anchor, they are similar, but for the purpose and the potential, they have huge differences and huge different directions. Yeah, that's my answer.
Wonderful.
Mm.
Great. So I think, given the time, I'm good to go. So Frank, feel free to take it away.
Thank you.
Oh no, I'm okay. I agree. Like Kai did an amazing job, and also the
Thank you.
presentation went very well. And I like all the slides with the visualizations. Are these all created by yourself, or some of them are like AI assisted? Because these are very high quality graphs.
Gemini helped me a lot.
Oh, I see.
Gemini Nano helped me a lot.
Okay. Okay, I see. Thanks. Hmm.
Okay.
Do you have any question, Frank?
Oh, not for now, for the public.
Okay, good. All right. So I would challenge you one thing then is memory regarding, I think memory, so some of your work and recent works, memory will need a maintenance, right?
Yeah.
So the memory is not that you create one thing and you keep adding those, and then this will be a lot of noise and the memory will increasingly big. And when you getting more and more information load into memory, and actually the memory will be polluted maybe. And also some recent experiments and recent part of my research will need to engage like a memory, we call that memory disentanglement. So for example, when multiple people share the same account, for example, when I purchase GPT account, sometimes my daughter will use it, sometimes my wife will use it. And so when we purchase like Meta Glass, I have one, which is very expensive. So sometimes I wear it and my child will take it away. My wife sometimes use it a little bit. And so the memory, entangled together. So then we say the memory will need some disentanglement or need maintenance. So when we deal with those, we can say either entangled memory or polluted memory. So how you deal with it from some of your existing framework or your future work, how to deal with it.
I mean, this is actually a very challenge problem, and I never seen this problem before, but it's nice to have it. It's unseen. It's very hard. It's a very hard question, but very great. Let me think for like 10 minutes, 10 seconds. So when we want to solve a problem, we first want to analyze this problem. So disentanglement. I would say if you have implicit disentanglement, like you use your AI, and then maybe some of your family use it, but without explicitly tell the AI that now is switching to another people. So this is very hard to solve because your AI needed to know to decide it if this is your style or if that's not your style. So when we hear, I would like to call it out that actually this is actually Meta's work, not my work. So they are developing a kind of model that calls Siri of user in mind. So this model actually will have all your users' histories and generated a profile. So one way to do this is like we have when you have a profile, then it is fixed. It will dynamically change, but it's slowly. A person would not like yesterday I'm a very easygoing person, and then the next day I become a very hard to deal with person. So you won't change dramatically. So your profile would stay in a stable state, and this can be detected by IL agent. So once the way you use AI or interact with AI changed dramatically, then disentanglement is detected. Then you will have some kind of following engineer work to deal with it. So that's one way. And there is another situation that is maybe your friend, your family directly or explicitly tell AI that I changed. That way it's actually easy to do. You can just have a memory for you, and like the in-memory reasoning work, you have a shared memory. Then you have your side people's memory into the shared memory. Then you can maintain them in the traditional way. So and actually I want to call it out as the third one. Actually, this is also the answer to Professor Raish Raga's questions. Is what I'm very interested in the next step of my research is proactive AI. So a key difference is for memory and the RAG is also here. It's like RAG is more like when you query races, then I need relevant informations. But for memory, we are not limited at this level. We wanted the memory to proactively respond to you, like meta AI glasses. Maybe you park in a shopping mall, then you don't have to tell meta AI explicitly take a photo of my parking lots and tell me later. No, you don't have to. So your meta AI would detect that this scenario is necessary to store the memory. Then it takes the memory, and then it goes to and then when you need it, it will proactively approach to you and activate the memory for you. So same solution here for Professor Liu's questions. So when we have disentanglement, I think one way is to have RL detection, and then another way is proactiveness. So you proactively track your users' preferences or interests or profiles. We call it profile. We call them. So if your profile changes like in a dramatic way or above a threshold, then you know that it's shifted to another people. So that way you can do the following processing. So yeah, that's my answer. Hope it helps. That's my best. It's really a hard, good question.
You can take a look at some recent works about agent memory and the memory isolation. I think some of that address that, but not fully address the memory disentanglement yet.
Yeah.
I think this can be a very interesting topic I would like to explore in the future.
Yeah. I totally agree. strongly agree.
So thank you very much. I appreciate everybody. So it's the time for the committee member to ask some question in private. So thank you very much for those coming today, either online or here residential. I appreciate everybody's participation and your support. Okay. And you may need to leave the room, and committee member will ask some question.
Okay.
Thank you very much. And Kai, you need to remove someone online if he's not
Okay.
part of the committee. Thank you.
Oh, can people online that is not committee go out? Sorry, now it's committee time. Sorry. I don't know like how. Okay, I think.
Sorry, everybody need to leave it, but dog can stay.
Yeah. Oh, God. Thanks.
Sorry, I'll see you later.
Thank you.
Thank you.
I think Kai, you can just go to yeah,
Okay,
you're
cool.
all set.
Thank you so much. I'll leave.
Okay, great. Right now it's just committee time. So no, wait. You need to come back. Yeah, we will ask you some question maybe.
Okay.
Yeah, first. Okay, Kai's still here. So committee member, before Kai's leaving, do you have any? So right now just committee and Kai. So is anyone have any question for Kai?
Yeah, I think Kai, for the project, when you talk about using the recent memories, so I see in the slides there are some tuning parameters. Are these data set specific, right? So you have for each different data set or topic, you have to tune that in order to have better performance.
Uh,
So can we borrow information from other similar data sets? Like in statistics, we have a meta-analysis, although it's not on the same specific disease, for example, but you can use meta-analysis to borrow information from other diseases. I wonder if this applies to your case. For example, if you're talking about some some type of say lung cancer, but can you also borrow information from other skin cancers, things like that? Mm-hmm.
yeah, actually, that absolutely a great point, and that I think this is already included in either in the in-memory reasoning and also
Mm,
the work I have done for the graph NLP applications. So if you can see in this slide,
mm,
yeah. So here actually I have external information which is from the previous cases like the disease or acumen of a drug or why you are using this drug for this disease, this kind of clinical trials information and publication research. So this kind of information is actually distilled in the teacher side. Then it will be
mm,
tuned to the large language models. Then large language models can have this kind of information. I feel like this is an example of what you have described on this track. Yeah, and absolutely we should use the meta analysis and the information from others communities to approach the human intelligence. 'Cause I feel like one way human is better than AI is we can learn from others, we can learn from errors, but AI cannot. AI can only learn from what we teach them to learn, right?
mm.
Yeah, so totally agree
Okay.
with this point. Thank you so much.
Yeah, that's good. Thanks. Mhm.
Thank you. Ronnie, you have any question for Kai?
I'll add one more question just for the sake of it. So, Kai, can you talk a little bit in the context of memory about the problem of cold start and, did you address it? What happens if you have a cold start problem? Essentially, a user comes in and you don't have any associated memory. What does your system do? And if it does not, if it assumes that it does not have a cold memory issue, how you would address that. So if you can just talk about this a little bit, and we'll be good to go.
Yeah, that's also a very great question. I think this question is also included in my research qualifier. So for code start, it's actually very hard for memory scenario. Because imagine if we just met a new people, so we have some kind of stereotype of humans, like oh, this is Asian, and it like 7 inch tall and fat or slim, this kind of things. This is from our past experience. So when we hear is also learn from past experience. This is a cognition. This is how we recognize how we recognize the new things, or we call it associative memory. So the one thing we can do is to have an associative memory that's doing the things what I just described, that like generated a profile for the new coming user based on your understandings or interactions with the other users in the past. So that's one way to deal with the cold start. And the second way is to ask the user explicitly to click on some selections. Like when we are new to a lot of apps today, so before you doing the registration or before you are start using this app, it will pump out a lot of questions like what's your interest, like what's your gender and the basic information, a lot of things. So you can collect the data just like this and train a model. Just use the patterns from millions of users that have this kind of information. Then you can have a profile. You will know, like for a community, that this user is interested in sports. That likely it will be interested in NBA or tennis or something like this. So you can have a general profile, and you can generate a profile based on your past experience. I think that's also one way. But this way is like a user AI collaborations is on the human AI interaction part, right? So two way. One way is learn from past, associative memory generation, and the second way is to do the human AI interaction or human in the loop AI. Yeah.
Thank you. Very interesting question. Actually, we will have a KDD paper next week about a memory code star. So I can share with you, right? So
That's
Wonderful. Yeah, I'll be happy to hear about it. Yeah.
good. All right. So then thank you very much, Kai, for your very hard work. I appreciate your efforts during PhD journey. So it's about time you leave the room, and committee will have some discussion and we'll call you back. So don't go far away, and we will call you. Okay?
Thank you.
Thank you very much.
Thank you.
Okay, thank you very much. So right now in this room, just three of us. Okay. Once again, today we can only give him a conditional pass or conditional fail because we need to get another opinion from Professor Kim. Unfortunately, she's right now is have a medical leave, so she cannot join us today. But once again, we will share this video recording with her and get her opinion. So if she's has some she disagree with our decision, so we will have some further discussion by email. But I will contact with her. Probably gonna take a little while for her to get back to us. Okay. But so give us some patience. Okay, so just three of us, but we can make a decision for now. So we can give him either pass or not pass or conditional pass. So what's your opinion?
Of course, it pass from my
Pass.
side.
Thank you. Frank, how about you?
Same here. Yeah, definite pass.
Okay, great. Thank you. So he
Mhm.
got 3 votes pass. So without concern. So thank you very much. I really appreciate your help and your contribution for Kai's career. So I will bring him back. But once again, I will need to provide a video recording to Dr. Kim, and
Mhm.
she will give us another vote. And if she's agree with us, then great. We will sign this, give him the signature. So I think he will pass. But if Dr. Kim do not agree with us, I have a different opinion. So we will have another. I'm sorry, we will have another either email conversation or we will have a Zoom meeting for the final decision. Okay.
Mhm.
Thank you
Sounds
very
good.
much. I appreciate it. Give me a second. I'll bring him back.
Sure, sure. Uh, oh, so Roy, is everything good?
Yes, yes. How about you? How is were you guys affected anyhow by the storm or not
Okay,
really,
come
right?
back.
Oh, not directly because we don't have any snow, but this weekend, this Saturday and Sunday will be very cold. Yeah,
Yeah.
we're also
Yeah.
hitting like a
Keep
20,
keep
22
warm.
something.
Yeah, but it's much better in Florida, I believe. So, okay, we have a good news for you, Kai. So congratulations.
Mhm.
We three of us give you pass. So, but I cannot call you Dr. Zhang yet because we don't have a vote from Dr. Kim yet. So right now I can give you a conditional pass. So which is great. So this is fantastic. Very,
Mhm.
very, very, very great job. But the next step is we're gonna give this video recording to Dr. Kim, and Dr. Kim hopefully she will, but probably it will take a little while because
Mm.
is taking a medical leave, so
Yeah.
we probably need to wait a while. So if she
Mhm.
agree with us, so then you get a pass, and we will finish the paperwork, and then we can call you officially Dr. Zhang. So congratulations. But if
Yeah,
she's disagree
congratulations.
with us, of course, and she will, we will have some committee discussion, and I will let you know the result. I will let you know the opinion. Okay.
Sure.
Otherwise,
Sure.
but I
But
think the three of us
for
all agree you did a very good job, and
Thank you so
a
much.
lot of work, a lot of during past 4 years. It's my pleasure, and I think other people's pleasure to work with you, and you do a very good job. And especially, I'm very impressed. It's more than your publication. You make a real world contributions to to Meta, to Google, and to Alibaba. So which is really good. So your research,
Mhm.
I think, more than just academic papers, but also you make contribution to the real world communities, especially your efforts to help the patients for patient memorization, which is great. And I really hope, and I believe committee also hope your efforts will continue and
Mhm.
give us keep impacting work for academia and the industry. We're looking forward to that. Okay.
Yeah,
Thank you so much.
Thank
definitely.
you once
you.
again.
Thank
Congratulations.
you so much.
Thank you.
Congratulations, Kai.
So how about
So,
that? Let's take a picture.
Yeah.
Can you make it a bigger one?
Are
And
you in Unity?
photo?
Are you
Can you
guys?
help us to take the picture?
How about this?
yeah. So, Kai, do you have any like a pressing deadline or job offers that you need to go to before the? Mm-hmm.
I actually have some offers, and I have already made my decision to Meta Reality Labs for the smart glasses
Oh, that's
AI
great.
development. But
Tell
Yeah.
Luna I said hi.
what?
Tell Luna Dong that I said hi. She's awesome. Are you working with her directly with
Yeah,
Luna Dong?
I work with her directly. She's awesome. She
Yeah,
actually
Oh,
have
she
a
is.
very firm thinking on research and
She's awesome. Yeah. Are you guys in Unity?
in Unity. What do you mean?
Unity Hall? Are you
Oh
guys
yeah.
on
We are in the Unity.
Yes. Good.
Yeah, I'll drop by. I'll drop by. I was a bit late, so I joined via Zoom, but
Oh,
I can come for the
good.
Sure.
Come here.
Sure.
471. Okay.
Was-
Room
Great. I'll be there in a
471.
sec.
Yeah.
Sure.
Come here.
471. Okay.
Yeah,
Okay.
sure.
Good.
Thank you.
Good.
oh,
Yeah.
and then
All right.
so you basically you're joining like is there California site, right? Or
New
Mhm.
York. New York.
Oh, New York site. I
Yeah.
see.
Not far
That's
away
good.
from us.
Yeah.
Yeah,
Need
not
to
far
suffer
away.
from the cold weather.
Oh,
Yeah.
Right.
actually, I had a lot of discussions with Professor Liu on the career choice and the selection.
Oh,
And I have no idea if I selected the offer right or not. But actually, just like in research, there is no right or not. Maybe just feel it and push it. I feel.
right.
I don't know tomorrow, but from
Uh-huh.
yesterday's stock price, you did a very good job. Meta stock price jump up like 7% yesterday.
Oh,
And after hours, because they did Meta is increasing. All the other companies, including Microsoft, I think dropped down like 10%. So today
oh,
Nasdaq have a big fall. Well,
right.
Meta is probably the only one who jump up.
Who jump up? Oh,
Yeah.
All
I
right,
see.
great. So Ryan, you can come here and we can give Kai a picture. You can stay in
Thank you
the
so much.
middle. Thank you very much.
Please take more.
Great. Thank you very
Mhm.
much.
Good job.
Yeah,
Okay,
Thank
good
you so
job.
much.
Yeah,
thank you, Frank, for joining us. Thank you, and
no
enjoy
problem. It's my pleasure.
beautiful Florida weather. Okay,
Yeah.
we will find a time to visit you for the visit you
Definitely.
and visit the warm weather.
Yeah. When you come to Orlando, just give me a call and yeah, we can get together.
Thank you. Thank you. Looking
All
forward to
right.
that. Thank you very
Yeah.
much. Okay, thank you. Bye.
Yeah. Bye-bye.
Bye.
3 years, Luna has went to a different place and stuff like that. So you can always move, and
You can close the Zoom because. Thank you, Rai, for coming. Thank
How was
you.
your trip?
This good.
Yeah,
But
yeah.
still suffer from time difference.
Oh, yeah.
It
你的线
was
Okay.
Singapore, right? Singapore, yeah,
Yeah.
pretty far away. Oh,